Greetings and welcome to my OpenVZ presentation. My name is Scott Dowdle and I'm a member of the Bozeman, Montana Linux Users Group. I'd also like to promote a website that I manage. It's montanalinux.org, and my email address is dowdle, D-O-W-D-L-E, at montanalinux.org. And I'm here to talk about OpenVZ. The scope of this presentation, I'm going to give an introduction to OpenVZ, briefly discuss how it compares to other virtualization products, discuss the OpenVZ components, and then I'm going to use OpenVZ in a live demo. Hopefully that'll go well. I'm going to install the OpenVZ kernel, create a template cache from which I can install virtual private servers, and then I'm going to create a few of those, and then I'm going to play with them so you can see how they work, and do live migration from one physical machine to another. Why use OpenVZ? Well, OpenVZ is a virtualization product. It's from SWSoft, or should I say it's sponsored by SWSoft. Their commercial product based on OpenVZ is great. I got a phone call. Okay, let's see if we can do this without being interrupted again. One of the most popular virtualization types out there is VMware, because it's been around for a long time. They basically have two types of products. They have the desktop type product, which they give away VMware Server for free. Then they have a paid version that's called VMware Workstation that has a few more features. And then they have an enterprise product or a server product that they call VMware ESX Server, and I believe they've renamed that to Infrastructure. That is a bare bones operating system that you can install on the machine rather than with VMware Workstation you install that as a program on a desktop operating system. Well, VMware ESX is actually an operating system you install in the bare metal. And then another really hyped up product is called Xen, which is a hypervisor or paravirtualization type of virtualization. And basically a hypervisor sits between the hardware and the operating systems that you want to run. Both VMware and Xen are full system virtualization, where each virtual machine is a complete virtual machine with a kernel, all the kernel threads and services that a full-blown machine would use. And so they are fairly heavy, but they work well and they're very efficient, but they don't scale well. You can't put a whole lot of virtual machines onto a physical machine, simply because mainly the memory requirements. So with those, if you wanted a server, you'd probably want to dedicate 512 megabytes of memory to it, and then you'd have to divide your memory by 512 to see how many virtual machines you could get with Xen and VMware. Of course, 512 megs of memory is just an example. With OpenVZ, it is a process container type of virtualization, which means your host machine is able to group processes together as if they were virtual machines. From the context of the user inside the grouped processes, we'll call that a VPS, or a virtual private server, or a VE, or virtual environment. It seems like a full-blown machine. They've got root access. They can create accounts. They can customize the config files for all of their server applications they want. They can install software, all without disturbing the host machine and any other VPSs that might be on that host machine. And because it's just a group of processes, the VPS only takes up the resources that that group of processes would require. So your VPS really only runs the services or the server applications that you need or want, with a couple of additional processes like syslog and cron, so that you can do some normal background work that you'd need on a virtual machine. So as a result of being very lightweight, you don't really need to dedicate a lot of memory to have a VPS. You just need as much memory as the processes you want to run need. And there's only one kernel on the whole machine rather than a kernel inside of each VPS. So you have native performance. You also have dynamic resource allocation, which means you can change how big the disk is inside the VPS, how big the VPS thinks its hard drive is. You can give it more memory if it needs it. You can let it run more processes or scale back the number of processes it can run. OpenVZ has a concept called user_bean counters, and there's probably about 20 or so resource values that you can set and tweak, including network, packets, and how many ports and connections, and how much memory and how many memory pages, and all that sort of thing. It was originally designed for Red Hat derived distributions. It's RPM based. It works fine with Yum. They have a Yum repository. However, it's been put onto Gentoo, SUSE, Mandrake, Ubuntu, Debian, quite a few. It's easy to install for the systems that it's available, and it has good management tools. Like I said, it excels in resource management, and they've added checkpointing and live migration features. Checkpointing allows you basically to freeze your machine, save it to a disk, and start it back up whenever you want to. It's another way to back up your machine as well. Live migration, or you can do offline migration as well, allows you to migrate a VPS or a running VPS from one physical host to another. Live migration does it without losing any uptime or network connections. So it's like the machine moved from one physical machine to another without anyone even being able to notice, other than maybe a few seconds of network outage. If you want to see all the features of OpenVZ, visit that link there. That's wiki.openvz.org/features with a capital F. OpenVZ is made up of a kernel. You have to install the OpenVZ kernel onto your Linux machine in order to run OpenVZ. And that adds additional features to the kernel needed to create VPSes, virtualization and process isolation, the additional resource management features, and live migration and checkpointing features. In addition to a kernel, you have various tools that you use to create, monitor, and manage your VPSes and your OS template caches from which you create VPSes. And then there's your templates. Now, there are two types of templates. One that you build from some distribution media. Usually you download all of the packages that you need for a particular distribution, and it will install them to a temporary directory and then tar-gz that up into a big tarball, and then delete all of the temporary install files that it did. Or you can download big tarballs of various distributions that other people have made, and then you copy that into the VZ template cache directory, and boom, you can create VPSs from that canned type of template cache. I prefer to create my own template caches because that way I know where it's been. And now I'm going to go into a live demonstration, but first I want to tell you a little bit about what I'm going to be doing here. My console, you have 4 tabs down here at the bottom. Backup 1 is a machine already running OpenVZ. Backup 2 is a machine on which I'm going to install OpenVZ and do all my demoing. Devel 4 is the name of a VPS I'm going to create. Doesn't exist yet, so I'm not logged on to it. And then Devel 4 is going to be another VPS. So the plan here is to install OpenVZ on Backup 2, get it going, create a template cache, create a couple of VPSs, play with them so you can see how they work, and then I'm going to try to migrate one of the VPSs to Backup 1, show you that it's working, and I'll be connected to both VPSs, and then I'll migrate it back to Backup 2. Okay, so first let's install the OpenVZ kernel. Now, the OpenVZ website has a really good quick installation guide. And the first thing we're going to do is install it via Yum, and they have their own repository. And here's a link to it. If you see down at the bottom corner, it says download.openvz.org/openvz.repo. If you're familiar with working with Yum and repositories, this is fairly easy. So on Backup 2, I'm going to cd into the etc yum.repos.d directory. You can see I've got a DAG repo in there, and then the stock Red Hat Enterprise Linux. I'm going to wget download.openvz.org openvz.repo. Okay, there it is. Let's look at it real quickly. It says in the comment here that this is pre-configured to work with Red Hat Enterprise 5. So I'm not going to have to change anything. You can see that this is not commented out, and the OpenVZ, well, let's see, that says enabled equals 0. This says it is enabled, so the Red Hat 5 kernel is what's enabled. You can see they have various other kernels, so if you want to use them, you can. And then they have a utilities thing as well here somewhere, I believe. Maybe it's at the very top. Yeah, there it is at the very top. Okay, so that's enabled. All the rest of them are disabled. So now that we have the OpenVZ repo, we can just say yum install OVZ kernel, and I'll let that work. We'll go back to the thing here. Basically, that's the content of the well, we already looked at it. Okay, so we're going to install the kernel. So we're yum install OpenVZ kernel. Flavor would be SMP if you had a SMP machine. You can use RPM if you don't like yum, but then you'd have to download all the packages. All right, let's see if that's done. It's working on it. They have a lot of mirrors, and it looks like he didn't like one of the mirrors, so it's going to try the next mirror. Oh, it would have been nice if I had this locally here, so it would be faster. I'll just pause this again. Okay, it's decided it's going to download and install the kernel. It's 15 megabytes. So we'll just let it download. I have a fairly fast connection here. Alright, it's about done downloading. There we go, it's installing. And it is installed. So there are two additional steps after you install the kernel. One is to check your bootloader configuration to make sure the OpenVZ kernel is going to boot. And the second one is you need to add a few additional settings to the etc/sysctl.conf file. So that's covered in the installation guide. We'll come back to that in a second. So let's cd etc. One thing I like to do is back up the original. So I'm going to copy that to .factory. So I have the original. And let's go back to the quick installation guide. Here's what they want you to add to that file. I like Nano as a text editor. sysctl.conf. I'm just going to go to the bottom and paste that in. Now there's some values that are repeated in there, but the last instance of them will be, clobber over the original. So we've got that in there. And now we want to look at our grub bootloader configuration to make sure that OpenVZ is going to load. And no, it's not. Oh, yeah, it is. It's just right here. This is what was installed. You can tell by the name of it. I'm going to give it a new name though, so it's easier to make out on the menu. I'm also going to put it last on the list, and so I'm going to call this OpenVZ Red Hat 5 stable. Okay, so I've installed the kernel. I edited this sysctl.conf file in the etc directory, and then I made sure the OpenVZ kernel is going to boot. So let's reboot our system. Oh, if you want to see what kernel we're currently running, it's the stock Red Hat Enterprise Linux 5 kernel at the time I made this. Okay, so let's shut her down. This is a remote machine that I'm SSH'd into. So let's log off. I'm going to pause for a few minutes here until it's connected again. Okay, the machine came back up, and now we're running the OpenVZ kernel. So what's next? Well, let's look at our quick installation guide again. We need to install the utility programs, and this is what they want you to do. Yum install VZCTL, which is the main control program, and VZ quota. Hopefully this won't take as long as the kernel did. We'll see. Yes, I want to install those, and they need the VZCTL lib to get all the dependencies. Plop, plop, plop. Okay, that's installed. And now we want to start the OpenVZ service. Just so you know, that installed the VZ service. If you want to see what run levels it's set to run in, it's set to run in 3 and 5 by default. chk config -- list VZ. You can see it's set to run in 3, 4, 5, and 2. Who uses those? I'm in 3. So I'm going to start the service. And it is started. And let's look at the status. And it's running. So now, what's next? We're going to install a template cache. Again, let's go to the download section of this is OpenVZ main website. You can go to the download. We're going to use Yum for everything, but I wanted to show you that the kernel, the utilities, we've done those, or most of those, and then the templates. And it tells you there's metadata packages, and then there's repo caches that just have all the packages that you can just download all the packages individually if you wanted to. And then there's pre-created. Pre-created are where they've tarballed various systems, and you can say they have a ton of different types from ones that they have metadata packages for to ones that they don't. Here's Debian 3.1 for different architectures. Wow, there's a ton of them. Fedora Core, Gentoo, and then those are made by the OpenVZ folks, and these are made by community members. And there's also a CentOS 5, Debian 4. So you can download those. You can see they're quite big. Some of them are pretty small, actually, but there's not much pre-installed on them. What I'm going to do is create my own template cache. So you can read through this when you have time, but basically, here's what you need to install: some additional utility programs. One's VZPKG to manage your packages, VZYum, and then support programs. So let's switch back to our terminal and let's install those. While that's going, let's read what this says here. Make sure you understand what an OS template is, what template metadata is, and what a template cache is. Template metadata is basically once we've installed the utilities, we're going to install the metadata package for CentOS 4. That's an RPM package that just contains a definition of what software packages make up CentOS 4. And with that, it doesn't contain the packages themselves. It just defines how one would install CentOS 4 and what packages would be necessary. And then we'll run VZPKG cache to actually process all of those packages, temporarily install it to the file system, and then make a big tar ball out of it. And then from that we can create VPSes. So let's see if it's done. Oh, yes, it's going to install 49 megabytes. And rather than watch that, let's switch back over here. What we're going to do is create an open template cache using the template cache utilities and the metadata package. So right now we're installing the utilities. I use Yum rather than RPM. Once we're done, we're going to install a metadata template for CentOS 4. And I'm going to pause. Okay, those are downloaded and they're installing now. Okay, now we're going to install a template cache. So let's see what template caches are available. I'm going to Yum search for VZTMPL, and I'm going to grep for i386. And that'll show us a list of template metadata packages that they have. They have one for CentOS 4, Fedora Core 3, 5, 4, 6, and 7. Well, I want to do a CentOS, so I'm going to Yum install VZTMPL. Well, let's just paste the darn thing. There we go. And it's only 127K, but it requires VZ RPM, so it'll get that too. That'll take about 20 seconds. Okay, so what is that metadata template package? Let's just get a list of what was installed by that package. And you can see it installs everything under VZ template CentOS 4 i386. There's a directory called config, one called add-ons, and then the add-ons are basically dummy packages that replace some of the real system packages. Like the make dev is a little different. Anyway, this file right here defines the packages that make up CentOS 4, this really minimal CentOS 4 install. So I'm going to edit that file and add a couple of additional packages that I like installed by default. I can install them after the fact, but I'd rather them be there on all VPSes that I create. So let me edit that file. You can see it's basically a long list of packages that you want installed. And I'm going to put a little comment here, added. I like Midnight Commander, I like Nano, and I like Screen. Anything else? I think that's about it. Oh, I know, Yum. I like Yum. Okay, so now that we've, you don't have to do that, but to add those additional packages, but I like them. So anyway, so let's use the vzpkg cache command and say create a cache for CentOS 4. That's the syntax of that. And now what it's going to do is going to process the definition for the CentOS 4 distribution for all of the packages that I wanted. It's going to grab all the dependencies for all of the packages and figure out exactly what it needs to download everything, and then it's going to install all those packages to a temporary directory, and then it's going to gzip that up and tarball it and cram it into the /vz/template/cache directory, and we'll come back to that when it's a little closer to being done. Okay, it's figured out it needs 182 packages, which equates to 131 megabytes of compressed download. And it's downloading all the packages. I'm not going to sit here and make you watch all that, but you can see it's not going too slowly. We'll come back when it's about done. Go Yum, it's your birthday. Go Yum, it's your birthday. Alright, it's done downloading everything. Now it's going to actually install everything. Since this is doing network-based downloading of all the packages, it is also including all the updates. So our template cache is going to be up to date as of when it was created. So there's no having to run updates and download a whole bunch of updates after you create a VPS. Again, this is the part of this installation part of the template cache creation. You can see it's going pretty quickly, so I'm going to just let it keep going rather than pausing. Again, it's installing it to a temporary directory, and once it's done installing, it's going to just make a big tar gzip of that. It's okay to get little minor errors like this in there. They're normal. There's only a couple of them, so don't fret seeing something like that. That telnet error there. Alrighty, winding down to the end. 182 packages takes a minute, doesn't it? Our favorite web server there. Then it showed us everything it installed, and now it's again, there's one of those innocuous error messages that happens every time I create a template cache. It's making CentOS-4-i386-default.tar.gz, and if you recall, it's going to put it in the /vz, which is where everything related to VZ is. Let's load Midnight Commander. Oops. Looks like my host machine doesn't have Midnight Commander installed, so I'm going to install it real quick here, because I like to use it to visualize things. Alrighty. Let's cd to the VZ directory. Here's the template directory. There's the cache that was created. You can see that's the name of it, and it's approximately 114 megabytes, it looks like. If you look in the CentOS directory, this is where that conf file was that we edited, the default list. If you look in the yum cache, you'll see all the packages that were downloaded. So if you don't delete them, you can quickly rebuild a cache. You can run the vz-pkg cache command again when updates come out and rebuild your cache so it's current with updates that came out since the last time you built a cache. Alright, so that's that. So let's build our first VPS. So we're going to create two VPSes. VPSes have an ID number. For the first VPS, that ID number is 555. I chose that because the IP address ends in 55, and VPS IDs have to be greater than 100 for some reason. And then I'm going to create another one, which is 557, and its IP address will be end in 57, so that's why I call it 57. So we use the vz-ctl command for most of everything here with the parameter create. We got to give it a number. We're going to say our OS template is CentOS 4, and then we're going to use a basic configuration template that's given to you by OpenVZ that sets some resource defaults, so you don't have to specify a zillion resource defaults. You can look at that if you want. We'll come back to that later. Then after it's created, we're going to give it an IP address. We're going to give it a host name. We're going to tell it what name server to talk to for DNS so it can get around the internet. We're going to start the VPS, and we're going to set a pretty bad password for root. Then we're going to create the second VPS. Alright, you'll be surprised at how fast this really goes. I've got a text editor here with my commands, so let's do the first one. Creating VE private area. VE again stands for virtual environment. You'll see VE and VPS used interchangeably. Alrighty, it's done. So what did it do exactly? Well, let's look at MC again. Go to the VZ directory. Inside the private directory, there's now a directory called 555. This represents the disk structure for our new VPS, and you can see it has a traditional root file structure that you would see on a machine. So, alrighty, so let's get back to what we were doing. Let's give it an IP address. Let's give it a host name. Tell it about a name server. And let's start that bad boy up. Okay, it's running. How do we know it's running? We can use the vz-list command, and it shows you it's running, its host name, its IP address, and it's got 16 processes running. We'll get into actually using the machine here in a second, but let's create that second VPS real quick. Oh, well, let's set a root password as well. Oh, I should have set a password for root. I think that's the right syntax. Only one user. Okay, well, let's do it this way. A-P-R-E-T-T-Y, bad password. A pretty bad password. Okay, it's set now. Okay, now let's create our second VPS. Again, that takes that tar.gzip file that's in the VZ template cache directory and extracts it to the directory 557 and VZ private. Let's look at that and see if that's true. VZ private. There we go. Notice those are the file systems for those VPSs. Now, what is root in the VZ directory? It's one a VPS is running. That file system is mounted on the root directory here. Notice 555 is running, so the files appear, but 557 isn't running because it's not mounted because it's not running. So let's finish up defining this VPS. I'll just do all of these at one time. Alrighty, that was fast, wasn't it? And it's running. So let's set a root password, and I'll do it correctly this time. Alright, there we go, VZ list. So let's verify that these are actually running. Well, first of all, what are these? These are virtual private servers. Let's look at them from the host machine context. I'm going to use the pstree command. I'm going to give it the NUP flags, send it to Les so we can look at it. You'll see this is the init process, which is the mother of all processes on a Unix machine. This is and all the kernel threads and everything. You can see quite a bit of stuff makes up a regular system. We will see other init processes for our virtual machines. So, okay, here's a second init process. Notice it's from the host machine context. It's got a process ID number of 10,057. And you can see all of the processes that make up that VPS. And then the next init process from the host point of view is process ID 11,131, and they're all the processes that make it up right here. So those are process containers. So let's enter vzctl enter 555. Now we're in the machine. We're on the root directory. There it is. Okay, big deal. Exit it. Let's go to our web browser and let's check out our website. devel1.cs.montana.edu. That happens to be the name we gave it. Oops, sorry, it's devel2. There we go. Oops, I know what that problem is. I believe I need to go to this machine and turn off the firewall. I have the firewall rules too restrictive right now. Normally you don't have to turn off the firewall completely, you just have to add rules for the services on your VPSs. Actually, there's several ways to do the firewalls. Your host can have a firewall and your individual VPSs can have a firewall. Right now it's in my way, so I'm going to get out of the way for the purpose of this demo. So I'm going to say service, IP tables, stop. Okay. Now we can get to our default web page. And let's open up a new tab and let's go to devel4. Boom, there we are. And now we can go over to the tab I've created, SSH root at devel2. And it was a pretty bad password. There we go. Now let's look at pstree. On here you can see init. The init process is process 1 from the context of the VPS, and the web server is running, and SSHD is running, and xinetd is running, and cron is running, and that's about it besides syslog and of course my login session here. So I'm logged into devel2. Let's log into devel4. I've previously created a machine called devel4 and it had a different key, but this is a new machine, so I know it's okay. Let me get rid of that offending key. It's line 116. There we go. Let's try it again. Yes, a pretty bad password. Alright. Boom, we've got 2 running VPSs. Now let's look at top here. There's top on devel2 and top on devel4, and here's our backup 2 machine. You can see it's got 125 processes. Each VPS has 19 with my top and my SSH session. So let's migrate a VPS. You can see they use virtually no time here, no processor. In fact, we've got plenty of RAM. This is a 2 gig machine. It's used up quite a bit of RAM, but you can see we still have a lot of free space and a lot of stuff used for buffer. Anyway, let's go over to backup 1 and let's service VZ status. You can see it's running. It happens to be running the same exact version of the kernel, so we should be able to do a live migration. We'll give that a try, and if we have a problem, we'll do an offline migration. So how do you do that? Okay. Back to my presentation here. Oh, on the file system, we've already talked about that. Oh, I didn't mention that. Let's jump back to that. On our host machine, all of OpenVZ's config stuff is in the etc VZ directory, in a directory called conf. Well, there's a master VZ conf. You can look at it, but I haven't ever had to change anything there. Here are our config files. There's our config file for VPS 555 and VPS 557, and that's a lightweight resource definition, and there's the basic resources, what we used. And what is that? That's where it defines values for the various resource parameters. Speaking of resource parameters, let's look at what those are. I'm going to quit top. Inside the proc directory, there's a file called user_bean counters. Let's look at that. This lists all of the resources that you have: KMEM, locked pages, priv, VM pages. You can see fail count would be if I haven't allocated enough resources. The held column shows you what's currently in use. This is what's the maximum that it's used since it's been running. This is the barrier, and this is the limit for the resource. Now, if your max held ever goes above your barrier, the fail count column will increase, meaning it had a resource allocation problem. By default, the barrier and limits are pretty low. So if you're going to start installing a lot of services or using a lot of processes, you'll need to update these values. Right now there's only 19 processes running, but by default it can run 65 processes. So what happens when this VPS wants to have a 66 process? Well, it will fail, and that fail will increase by 1, and if it tries it another time, it'll fail a second, a third, and it'll keep incrementing this fail count column. So you have to keep a watch on that and increase the resources until you reach a level where you don't have any more failures and you're all good. This gives you ultimate or optimum utilization of your resources rather than having to dedicate, say, a big chunk of RAM to your processes. You can see there's quite a few quite a few resource settings here, including send buffer, receive buffer, number of processes, and a lot of memory-oriented ones. I'm not going to go into all those. Check out the OpenVZ user guide for all of that information. Getting back to the host machine, these two sample configurations show you the default values for all of these various things. And the really lightweight one only has 40 processes. Oops, only allows for 40 processes by default. So that's what that's all about. Let's look at our conf for 555 real quickly. And basically it took the contents of that sample and then added some additional things like what we set: the host name, the IP address, and the DNS name server. Alright, so let's do a live migration. Let's get back to what I was talking about before. How do you do a live migration? Oh, we already looked at where things are stored and the template cache stuff. Talked about the template cache definition and how to create a template cache, and I'm in the demo. Okay, we're going to do a migration. Here is the syntax. You say VZ migrate, and we'll skip what the -r flag is for now. Keep destination, we'll skip that. Online means do it without any downtime whatsoever. I like the -v flag for verbose, and then you say what is the name of the machine you want to migrate to, and then you give the VPS ID number. So here is what we're going to do. We're going to migrate VPS 555 to backup 1. Our VPS 555 is currently running on backup 2, and we're going to migrate it to backup 1. So let's do that and see how that goes. I've kind of got a little, I guess I don't. So let me copy and paste that from my presentation. I'll just copy both of those. To my little text file here, because I don't want it to have all that gibberish. And that's a lowercase v. Okay. So here we go. Okay, we're on backup 2. We want to migrate it to backup 1, and that should be dash dash instead of that m dash. And that's just 1 dash. Oh, I know what that is. It doesn't know where my host is. Stand by. Let me fix that. Okay, I think I have the syntax of the command correct now. So there it is. There we go. Well, let's not do an online migration. There we go. Now we're actually getting something done. That's what I get for doing a live, recording this live without rehearsing it. And we're logged into number 2, so it should die on us here for a minute. It's syncing the private if you want to see that. We'd expect it to be. There we go. There's the stuff is starting to show up. And it's turning, so I must suspect it's done. Okay. So you can see there's only one VPS now running on backup 2. And now it's running on backup 1. What happened to our connection? It actually shut down before it started back up, but it was pretty instantaneous. If I'd have been able to successfully do the live migration, I would have been able to stay on to Dowdle 2 and wouldn't even notice, other than a few, maybe a couple of seconds of, oh, what's wrong? The network's not answering, and boom, it would be back to normal. You can see this VPS is running fine, so we'd expect. Let me log back into Dowdle 2. What was that password again? A very bad password? A very bad password. A very bad password. Or something like that. What was it? A pretty bad password. There we go. You can see our uptime changed. So anyway, but let's migrate it back. Let me kind of cheat and take that command. I'm going to change it. We can't migrate it to itself. Let's migrate it back to number 2. And since it already had a copy over there, it doesn't take as long to migrate everything. Not anything has changed. Stopping the VZ here, doing a second pass, shutting it down. And it's not up anymore. And now let's do our VZ list, and boom, it's running again. So that's OpenVZ. You can see once you've got a template cache created, you can quickly create machines. If you want to install software, what should we install? I don't know, PHP for our web server. A pretty bad password. Yum, install PHP, and we can do our thing. It's completely different user accounts, completely different software list than the host machine. All the VPSs are independent, but so far as from inside the VPS, it seems like a real machine. How much disk space does it have? By default, it's got 1 gig. Well, let's change that. Let's give Dowdle 4, which is VPS 557, some more disk. So let's, it's VZCTL set 557, and I forgot what the name of the parameter is, so let's look it up real quick. Less VZ conf, oh sorry, etc. VZ conf 557 conf, and let's look for the disk. It should be set to 1 gig here. Disk quota space, there it is right there. And you can set how many inodes you want each VPS to have. Right there is 1 gig. You can use a little friendlier syntax. Well, let me look at that again. Disk. So it's disk space, all one word, all uppercase letters. VZCTL set VPS 557 disk space, and then it's a limit and barrier. So we'll say 10 gigs. We'll save that to the config. Is it not disk space? Disk space. Let's do man VZCTL. My syntax, I'm not perfect on the syntax. Let me pause that and I'll come back in a second. In the meantime, we're installing PHP. I'll come back to that. Okay, I found out what my syntax error was. Disk space, when used as a flag for the VZCTL command, is all lowercase letters. All the parameters are lowercase letters rather than uppercase as you see them in the config file. So we'll do that. And what I meant by dynamic resource allocation, well, bam! Our disk size is now 20. Let's change it, or 10. Now let's change it to 20. Bam! Now it thinks it has a 20 gig hard drive. Let's change it to 5. I think you get the point. But you can do the same thing with RAM and how many processes, all dynamically. And so now let's edit our HTTP config. I have to get rid of the welcome page real quick here. Service HTTPD restart. We installed PHP. So now let's go to the default document root. Make a PHP test page. And then let's browse to that in our browser for Dowdle 2. Here's Dowdle 2. It should just give us a directory. There's our PHP page, and gosh darn it, it parses PHP and has PHP now because we installed it. Anyway, that is our OpenVZ demo. I hope you enjoyed it. Is there any other? Yeah, there's one more slide. Okay, I just want to talk about the resources. openvz.org is the website. The wiki is wiki.openvz.org. There's the link to the quick installation guide, which you can find in the documentation section. There's the PDF for the user's guide. That's a presentation by one of the authors of the OpenVZ kernel about how OpenVZ works and what it's good for and all that good stuff. And then there's Wikipedia's general virtualization page. You can learn about what is virtualization as if you didn't